All right, we are closing the doors now, so it's time to start. So this is IETF 119. This is IPSECME working group. I'm Tero Kivinen, and my co-chair is Joab, who is remote. You can probably say hello now.
Hello now.
All right. So, and our responsible AD is still Roman, I think, for
1 more day.
so some hours.
Hi, everyone. Yes, I am not going to be the responsible AD. And when we do the turnover, I'm the outgoing security AD. The good news, you are going to be in much better hands than me. Deb Cooley will be the responsible AD. So she'll do a better job than me for sure.
All right. So, so this is the note well. You should note it well. And we would like to have some note takers. There is already document in Hexbook to make something suitable for just adding the comments and so on. Noting to anybody willing to take notes? Michael? Yes. Okay. Anybody else to help? Okay. Thank you. So, and if you are seeing the Meet Echo, link, you probably already are in the Meet Echo. Here's our agenda. So we have some administrative stuff in the beginning, then document status, then several presentations, and we even have some open mic time in the end, hopefully like 10 minutes or so, if everything goes right. And any comments or discussion about the agenda? Anybody wants to add something or delete something? Nope. All right. So since we last time met, we have published one RFC. That was the Internet Key Exchange Protocol version 2 configuration for encrypted DNS. And we have one document that is in IETF last call, IK version 2 out announced. And then we have one document which had been already several hours in publication requested. We managed to get it out yesterday, or today. Actually, we were trying to put it out yesterday, but the authors were just, skipping some of the comments, so I have to put it out tomorrow, this morning.
Yes, pub wrecking the week of IETF. I'll have an AD review probably for you, before tomorrow.
All right. And then we have one document still waiting for a long time to be, to be done for something, which is GIC version 2. Valerie, I'll talk about that.
Yes, I just want to talk about this document. It was recently updated, and I believe that I addressed the remaining issues that I have in my mind, and also addressed a review from Daniel Migaud. And many thanks, Daniel, for this very sorrowful review, very long, and a lot of points, a lot of issues, minor issues were fixed. And I think that either we should try to push this document further, or it will stuck forever in this last call. It is already several years, I think more than 1 year in Working Group last call. So perhaps it's time to try to push it further. It's my opinion.
Yeah, I agree.
I agree on that.
And I will actually try to push it after. Actually, one of the problem is that I want to read it myself, and try to find out time to read it. It takes some time. All right, Roman, you have some comments?
Yeah, I just wanted to clarify something. For the one that says AD follow-up, say more. I am not tracking that as an AD follow-up.
No, it's not. Actually, it's waiting for a write-up. Right, it's waiting for a write-up is actually the status, but I think actually the data tracker shows it as that way, if I remember correctly. So it's cut and pasted from there.
Okay.
Yeah. Where it is. Actually, it should be waiting for write-up is the correct, yes, so. But I think we actually last time had some document that was waiting, and it was just a copy, got a old version of that, yeah. Yeah, it should be writing for a write-up, and that's actually meaning that as a separate I should be reading it, which actually takes some time. All right, then we have several documents that are working process. We have this TSP loads opt, and Paul has some comments on that.
Yeah, I can say something. That's actually still just waiting on implementation, specifically also because I'm not entirely convinced we got the spy handling right, that we can actually tell the difference between a child key and an ICRE key. So this definitely needs implementation to make sure that we didn't do it wrong. So that's why I'm not pushing it forward yet.
Yeah. Valerie, do you have any comments on QR alt?
Just a few comments. The draft, while it was an individual draft, it was it got some reviews from several people. For example, from Panway and Rebecca Guthrie, and I think that I've addressed all these issues, and actually, I believe the draft, even if it is just adopted, it is very close to working group plus call, unless some working group members and active members didn't pay attention before to it. But otherwise, I think it was in the focus on some active participants, in the focus of their attention. So it is already received some attention from the working group. So it is a bit close to the working group last call, in my opinion, even if it is just adopted.
Okay, good. And then we have the two new documents that were added there, which were actually delayed because they expired when I was trying to look them up, and then when they were expired, it doesn't show as working group adoption call initiated, so I didn't find them until they were sent again or reissued. And then we have this one. IPSECME IETF that is actually expired.
Are they waiting for working group last call or adoption?
They actually was adopted last time, and we had an adoption call December. In January when I was starting to or February starting working on them. At that point they were expired, and I didn't find them until this week. Paul.
So on draft IETF IPSECME IETF. So this is not an old relic from the updated IETF document that is already in RFC? Or am I mixing things up now? I thought the updated IETF was already in RFC. So is this an artifact? Or is this actually some other work?
I think this was, let me see. Yeah, actually,
let me pop up into this discussion. This draft is very old draft by Yoav Nir. It was written before the IC fragmentation draft. If you remember, there was some discussion. So it is a short live TCP connection. It used short live TCP connection, and then it was abandoned. And the reason why it appears in the as expired draft of the working group is an artifact of data tracker, because when the feature was added that expired working group drafts appear in a special section, the drafts that weren't abandoned by the working group, it didn't abandon. It just the work was stopped for it, but it is still a IPSECME working group document, but it is expired. So it just should be abandoned. And
I will move it as a dead document now.
Okay. Yes. It's the right action. Thank you.
Shouldn't be there anymore. Or actually now I think it shows as a dead working group document, which is different. But anyway, all right. So that should be our process, and then let's go to the actual presentation then.
Okay, this is a presentation.
You can also actually come here, and there's a separate screen for you. And just say next. Very good.
Okay. Okay. This is actually a draft by Panos Kanapakis, but he can't be here, so I am presenting for, on his behalf. This is for MLChem. Basically, this is the MLChem, of course, is a standard, is going to be a standardized quantum resistant chem key exchange for IPv2 to be used in both post-quantum hybrid and potentially pure post-quantum key exchanges in IKE. It uses RFC 9370, which basically has multiple key exchanges in succession, with the first one having not to be fragmented because of IKE fragmentation issues. But once this key has been established, we can then fragment freely, and so a larger key exchange is not an issue. The request is to define 2 or 3. The RFC the draft is actually pretty inconsistent for the 2 or 3 parameter sets. The MLChem 768, MLChem 1024, and possibly MLChem 512. Yeah, this MLChem can be used anywhere, essentially anywhere that a Diffie-Hellman can use potentially. Obviously, in the IKE intermediate and the IKE follow-up KEs to actually as secondary key exchanges. Also, possibly in the IKE SA init and the create child SA. MLChem 512 would fit actually relatively nicely as long as you don't go hog wild with the proposals. MLChem 768 should just barely fit, but the draft has a should not on it. The key material is actually, and how MLChem is actually used is the absolutely obvious one. We just use the key material just exactly as the RFC specifies. Updating the SKD, AI, AR, EI, ER, SK seed, and keymat. There are 2 open questions. Should they actually do a code point for MLChem 512, which would allow for a pure post-quantum key exchange? It would fit nicely in SA init, and then you can follow it up with an SKChem 768 or MLChem 1024. On the other hand, somebody could also just use MLChem 512 on its own for a slower security level. It is unclear if we want to allow that or not. Okay, and the other open question is, should this be go ahead with a IPSECME working draft, a working group draft, or can we just get code points from an export review? Given that relatively there isn't much here that needs to be specified. Any questions? What? Paul?
Sorry, Paul, do we need to specify not much or nothing?
We still need to say MLChem at least, and we really should, even though it's the obvious approach to use it MLChem, we really should spell it out explicitly, I suppose.
So then just do an RT working group.
Okay.
Hi, Ben, UK NCSC. I guess one clarifying question. When I last read this draft, it was kind of standardizing this exclusively as a hybrid alongside Diffie-Hellman. Is that still the case?
It is still intended to be a hybrid because it's intended to, the main use is supposed to be as a intermediate or follow-up. And so as intended, there always should be something in the initial init IKE SA, be that MLChem 512 or some of the curve.
Okay, cool. I guess one thing we could do, instead of having a draft specifically for MLChem, is you could have like a generic, here's how you use a post-quantum chem in IKE v2 draft, and then register a code point. Because in 10 years' time, you know, we've got 3 or 4 more chems. There's some like generic chem stuff inside this draft, like how to put the chem ciphertext inside the key exchange payload, and it might make sense for that to be in a more generic draft. And then you could then put recommendations for, by the way, you should use this as a hybrid until you're really sure in there.
Yeah, I'm sure Panos will consider it.
Thank you.
Quinn?
No, actually, I think next is Michael Rickardsson. I think.
Michael Richardson, please adopt it. In response to Ben, no, let's not make it generic. Implementers need to know what to implement, and making it generic just makes it, well, just do something, right? And I'd much rather have a document that says, here's 2 chems that are useful, go ahead, and in 10 years' time, we need more, we can get more code points. So I would like to adopt this document, publish it, even if it's like 6 paragraphs, right? I don't care.
I believe the issue was not more code points, but more RFCs.
Okay, Ken.
I'm Quinn Dang at NIST, and based on our analysis, we're strongly confident that MLChem 512 is more secure than AS 128. So we don't agree with the assessment that is lower than level 1. It's not accurate.
So question for you. So in that case, it would be actually very good to actually add it in the draft as a 512.
Yes.
So actually something that could be used in as, I guess, a init.
I support it. I recommend it.
Yeah, greeting from Huawei International, Singapore. So I have one question about some points. Could you show slides about Kyber 678 called should not?
That is should not be used.
Yeah,
as
so
an,
why it should not? Yeah, some
that
reasons
is
there?
should not be used in an IGSA init. It is because in the Panos's opinion, that was there's too little space for a more likely proposal.
So actually, I think it probably is in UDP.
Yeah. So if you're doing it over TCP, obviously not an issue.
Yeah. So in the IC version 2 in UDP, we have 64 kilobyte packet limit, and I guess the 7.
So about UDP, like the public size too big or something?
What?
Just too big.
Yeah. Yeah, and it's only in ICSA init. So when you go to the if you do the Diffie-Hellman in the first, normal Diffie-Hellman first, and then you can use this because then we can fragment it.
Okay. Yeah. Thank you.
Any other comments? Valerie, go ahead.
I also support adoption of the draft if adoption call is issued. So it is just the draft that follows the way that was supposed to be used when a generic framework was defined in RFC 9370, and concrete post-quantum chems are defined in very short drafts that just are used for assign a code point and explain how public keys are packed into key exchange payload. So it just follows this way, and I think it should be adopted. It's very useful.
Yeah, I'll just pile on, and yeah, same thing that we did with Cha-Cha 12 Poly 1305 was it? Yeah. We had a big document in CFRG that explained the algorithm, and then in both IPSECME and TLS, we had really short documents that used that, and here's the code point, and amounted to about 2 or 3 paragraphs. So yeah, I suppose I support adoption as well.
All right, I guess that's it then. Okay, thank you. So next we have ESP Echo Protocol, also called ISP Ping. Pong.
Yeah, we can come up with nice draft acronyms, yes. Hello, I'm Jen. It's my first time in security area. I'm horrified. Let's pretend I know what I'm talking about, just for 15 minutes. So I don't think it's been presented here, but we discussed it on the list because it's the second version of the draft already. So it's, as name suggests, about the ESP Echo protocol. Next slide, please. So just a reminder, everyone, even I know that. So in IPv4, obviously, right, we encapsulate ESP into UDP. So you have in IPv4 header, we know that protocol 17, and in UDP and destination port 4500, and then there is a ESP payload. In IPv6, though, situation is different. It's native ESP extension header, so basic IPv6 header will just indicate that inside we have ESP extension header and everything else is like hidden. It actually has some advantages. If ESP is statelessly allowed through your filtering, then you don't need any keep alives. If there are some stateful firewall on the path, normally ASP timeouts are higher than for UDP, so you don't need so often keep alives. And also, it might be small, but it's still some MTU advantage probably, right? You don't need an additional overhead. But there is always but. Next slide, please. So as a result, now ASP in IPv6 does not share fate with IKE. So IKE could succeed because it's UDP, and then your ISP might be dropped. And I'm here because I've been troubleshooting that stuff because some firewalls do that. And it might be just because they could not create a state because, oh my God, there is no ports. Or it's just because something else, so just MTU problem and so on. And as a result, it's really actually hard to detect and recover. And Lorenz, as an implementer, might probably tell you more about that. But basically, yeah, it's hard to detect that IKE succeeded, but ISP failed, and it's tried to switch. For example, like typical scenario, your device might connect to corporate network, and it has mobile connection as well, and it tried to use corporate Wi-Fi. And IKE succeeded, ASP fails. And actually, worst scenario which I've seen it's like Wi-Fi calling, which is actually IPSEC, and device just couldn't make calls because it's trying to use IKE, tries to use IPSEC, and after a successful IKE, it assumes it could make phone calls, but it actually could not. So it would be nice to detect that kind of thing. Next slide, please. Yeah, so what the draft proposes? Very simple. The proposed solution is to reserve two SPIs, 7 and 8, which will indicate echo request and echo response in ESP. So the IPSEC peer can just send, may send echo request before or after successful IKE negotiation. And if peer supports this, the peer should respond with SPI 7, next header 59, and it's important, which means no next header. So it means no payload inside. But and it must copy the data from echo request to echo reply, but up to MTU, right? So the response must not be bigger, obviously, but it could be smaller if, for example, the outgoing in like MTU for the peer is smaller than MTU of the original host. Next slide, please. Yeah. After discussion on the list, because initial 0.0 draft suggests we just have no payload at all. The current version, based on the list discussion, is let's basically do what ICMPv6 echo request and echo response uses. So you have identifier, which identifies particular ping session. You have sequence number to match packets within that session, and some data, which is basically some random garbage, but it might allow you to detect MTU on the path. Next slide, please. So 4303 talks about dummy packets, which are used for padding and send some random garbage on the session. And currently 4303 is saying that if your next header is 59, which means there is nothing inside your ESP, it's just like garbage, then the transmitter must be capable of generating them, and receiver must be prepared to discard them, right? In our case, we'd like to update the text and saying, yes, do this unless SPIs are from this reserved range, 7 and 8. In this case, it's not just a dummy packet, it's ASP ping, so please process as per this document. Next slide, please. Oh yeah, it's been discussion on the list. Yeah, why use just reserved number? It would be really awesome if we can troubleshoot real sessions with real SPIs and send those packets using production SPI numbers. So, however, there is a problem, right? Yeah, it would be nice if you sent a packet, ESP packet with real SPI, next header 59, and you will get a response through the corresponding SA. Yeah, I know that Michael might have some additional comments on this, but I actually started writing text for this. And then I realized we have a problem which I don't know how to solve. I'm not sure it's actually solvable, because as soon as you put next header 59, your receiver cannot differentiate between dummy packet and ASP echo packet, so it's basically would be dropping it, and it like makes total sense, right? Yeah, obviously using reserved SPI would be much nicer from troubleshooting perspective, for fade sharing, because yeah, you're actually talking about real session, and it would also prevent some bad people in the middle responding to your echo request with, I don't know, ICMP unreachable or like no route to host or anything. But again, I don't think it's solvable fundamentally, because next header 59 would mean dummy packets, and if you start using any other next headers, yeah, we need to put something inside, right? And that means stack needs to process it somehow. So yeah, so far that basically, yeah, we dropped that idea, only talking about reserved SPIs. And I know that Michael again has some ideas about how ping can be sent over production SPIs, but it's probably out of scope of this draft. Next slide, please. Yeah, security considerations. So the most interesting part here is probably what happens if the peer sends echo response and it does not get reply or get some ICMP back indicating that path is not reachable. We definitely do not want the host to fall back to unencrypted path to prevent the downgrade attack. So host must not do this. However, host should be allowed to switch to another path. For example, if host is multi-homed, like phone might choose mobile network versus Wi-Fi, or it could use other protocols like IPv4. So yeah, so the only thing, yeah, security consideration saying about this, like still stay on encrypted path. Potentially there are considerations about DDoS attacks and amplifications, but we intentionally saying that response will never be bigger than requests, so it should not be a problem, right? Theoretically, an attacker might discover that, oh, there is a IPSEC device on the other side, but it could be done with IQNIT or something like that. So again, security considerations mentioned that, but I don't think it's a real problem. Next slide, please. So open question, something which is not in the text currently, been mentioned on the list, but we'd like to discuss with the group, right, what to say here. So how does the peer know that the remote site supports this? Because let's say the device sends echo request and nothing coming back. It actually means one of two things, right? Either we have a problem on the path, exactly the thing we'd like to detect, or the remote site just doesn't support this stuff. I couldn't recognize this SPI. So obviously there is a way of explicit out of band signaling somehow magically you know that it's your remote site supports this. For example, if we would like to use it for corporate VPN, well, it's easy, right? It's a VPN configuration. I know that my corporate server supports this, and it's a part of configuration. It was mentioned on the list, so maybe it could be signaled in announced, probably the right word, in IC notify. However, there are some discussions between the authors. Is it really needed? Is it worth it? Or maybe it should be a part of the other draft, which I know Michael has some idea about, right? To just be able to send ICMP pings inside IPsec tunnels anyway. So basically the question is, would it bring any additional benefits to do this inside IC? Or the most compelling use case is actually just send it before establish an IPsec session, before you know anything about the peer from IC, and if it does not work, just fall back to another path. Is it worth adding complexity to including this as notify? And I think that's actually the next slide, please. Yeah, so questions, comments, and if the group thinks it's a reasonable idea, we would like to ask for adoption.
All right, Valerie.
I have a few comments about this draft. First, can we go to the slide number 2?
Yeah, could you speak a bit louder?
Can we go to the slide number 2 first?
Which slide? Number
2. Oh, well, I believe this is not completely correct, because both IPv4 and IPv6 can be sent either directly or inside or UDP encapsulated. So IPsec makes no difference. Just if you are talking about IPv6, the NAT devices are a bit silly for this case, but still it is not prohibited. And thus my first question, you define this ESP ping only for IPv6, and I think that if it is useful at all, then perhaps it should be defined for both cases, for IPv4 and IPv6. Well, okay, it depends on our area directions, ISG. Perhaps they said that it should not be supported in legacy protocols, but still. And
I'd like to comment for IPv4.
Valerie, can you mute your microphone for a second?
Okay.
Yeah, so for IPv4. Doesn't like before. Yeah, okay. Oh, works now. So for IPv4, it shouldn't be a problem exactly because of weight sharing, right? So it's rather unlikely for IPv4 that your IC succeeds and ASP fails, right? So this is more problem for V6 because weight sharing disappears, right?
Okay,
does it like?
I mean, there exists networks on which IPv4 ESP works. Not the internet, but there exist networks that do. So, yeah. You know, like there exist cases in which IPv4 ESP works. I don't think the proposal. I don't think we need to do anything different to support IPv4. So maybe we can just support IPv4. Yeah. I mean, the original intent here, though, is when you are sort of an unmanaged node trying to figure out if the network that you're on will support this. And yeah, on the internet, IPv4 ESP doesn't work. But yeah, you're right. If you have two site routers that want to talk to each other and you want to determine if native IPv4 ESP will work on that path, and you have public IP addresses, and you could use this. Yeah. So maybe we can just say we can remove IPv6 from this. It can just be ESP ping.
Okay, then I think that use cases for this ESP ping should be better spelled out in the draft, because currently the examples that are provided are not very compelling. For example, it talks that when you use Mobike, the path can change, but if you use Mobike, it is used when you already have an IC session. It is performed automatically. But in my impression of the reading of the draft, it is now supposed to be used manually or semi-manually. At least it is what Michael described. So some person should run ESP ping and get results. So I think that use cases should be spelled out very carefully, and otherwise it's a very useful tool, but whether it is intended to be used with a human operator, or whether it is intended to be used automatically when IKE client tries to connect, it should be spelled out. And in the later case, all the incorporated into the, perhaps IKE should have some connection with it. And the last comment, it is probably a minor comment, but I think it is important. The draft currently assumes that the fixed SPI are 7 and 8. I think it's wrong. We have IANA registry for this, and the next available values are 3 and 4. And anyway, it should be asked IANA for fixed values and not just make a Kyber squatting.
Sorry, yeah, I think maybe it's not clear in the draft and we clarified. We have IANA requirement sections, obviously. We just would like to ask for 7 and 8. So the draft is just saying like 7.
Okay.
And refers to IANA requirement.
Because it's just strange for me, because next available values are 3 and 4. So for some reason, you want to skip them. Next available fixed SPIs.
Okay, Paul.
Okay, Paul Wouters. So the problem, if you go 2 slides further, when you have the question on should you do IKE or not, right? Or maybe one more. The problem is you need to distinguish between an endpoint that doesn't support this and an endpoint where the traffic is actually blocked, right? And I don't think that has been solved in the discussions. That's why part of the people say we want IKE support, because we want the IKE server to say, yes, my kernel supports this ESP ping, you can ping me. Because if you don't have that, you cannot tell whether the path is blocked. And so this also depends when you're trying to do this probe, right? Are you trying to set up an IPsec connection and an IKE connection, and then when you see no traffic, you're probing, or are you doing probing first before you try to determine if you want to do NAT encapsulation of the SA? Because the answer might come too late for you.
I guess both cases are theoretically possible. I think, Lorenzo, do you have any comments on when you want to do this? But strictly speaking, the idea is if, for example, we're using it for VPN, right? You can know out of band that your VPN system supports this, right? Endpoints, I know like my corporate VPN supports this, so my corporate VPN clients can use this to verify ESP paths to the server, right?
But actually, even that is not guaranteed, because if there's actually a network where that server is behind NAT, then you're also not guaranteed that its kernel actually sees the packet.
But like in this case, like I control my server, right? I control my clients.
But do you control the entire network in front of it?
Like if it does not work, then like if I cannot verify end to end, I know the server would respond.
No, it's in a way worse, right? Because let's say there's a firewall that says like, every ESP number under 256 was reserved, so I'm just going to drop these packets. Then you're sending the probe, and the probe is getting dropped by somebody else, and then you think it's not supported, even though it is, even though a regular ESP tunnel would have worked fine. So you're getting a bunch of false positives.
But in this case, notify would not help me, right? Because if it's dropped somewhere in the path, and notify will tell me it's supported, and it's still dropped in the path. Or you say that a reserved SPI will be dropped while normal one. Well, yeah, I guess there is a risk in it.
I guess I don't really understand when you're going to probe and when you're taking actions, and if those cases align properly or not.
Well, you can probe before or after IKE, and if that path does not work, you can switch to another path if it's available.
So I don't think we recommend any specific algorithm here, and I don't think we should. This is just a tool that you can use to determine if the path to your server and potentially your server are within the limits of like middle boxes can do whatever they want, ESP clean. That's all, right? This is literally a way of saying, here is a well-known packet that we can use on the network to see if things between this host and that server are, capable of transporting ESP. That's all. And you can use it however you want. An example of how you might want to use it is if you don't support IPv6 UDP and CAP because your kernel is too old, you might not want to bother with IPv6 IKE at all because you can't support IPv6 UDP and CAP. And so you're just going to say, well, if ESP is not going to work, I'm just going to use v4, for example, because you're not so capable of supporting UDP and CAP for v6. So that's an example. But like I said, I think this is just a tool, right? I don't know that we want to write down all the use cases. We certainly don't want to limit the use cases. When people define the ping protocol, we didn't say, oh yeah, there are the things that you can do with it. This is just a way of saying, does it work? And I think obviously if there are harmful use cases or things that we shouldn't do with this or reasons why it wouldn't work, that's obviously an argument against this. But saying we don't know what to use this for, there's lots of things.
Paul, just to clarify and comment, but your analogy with ping doesn't really hold, right? You should say like ping now would always be dropping, and now I'm adding something that will reply to a ping. Like that's the situation is quite different from the deployment of ping, I think.
No.
Okay.
Create a trace route. We have no idea the trace route would exist when we create it.
All right. So this document as not as a chair, but as a so yeah. There is actually when you send this ESP ping, there's 3 different things that you can actually get back. You can get an ICMP protocol, prohibited, which is very rarely coming up, but it can happen that you actually get an ICMP saying that administrative prohibited, or you can actually get also saying protocol not, ICMP saying that there is no protocol 50 server on the other end, or you get an invalid SPI notification from IKE, which is also possible, which would actually indicate that the other end did receive this, but doesn't support this feature. Most of the devices don't send those messages. They usually send them only if their other end is recognized, meaning if you have a site VPN. But also one of the things you can actually do with this is that you can actually send this before you start IKE, and if you get response back, and you know that the other end supports it because it's from your configuration, then you know that you can actually safely try to use ESP because at least the protocol 50 goes through. But what you can, if it doesn't come back, you can do whatever, for example, mobile does or fake into the UDP tunnel. Either in IPv4 or IPv6. Actually, I think you can put a UDP tunnel also in IPv6 and it will work there, even if you don't have a NAT.
Sure, you have to put in a lot more logic, right? Because, for instance, if you're behind NAT and you're sending an ESP ping, then it's going to be used. Like if you like only when you do IKE will you know that you're behind NAT. Before that, you don't know that. So sending that ping beforehand is going to be a fool's errand, right?
No, not really, because I mean, most likely if you are behind the NAT, you are not getting response back to this in IPv4 because I say NAT travel not doesn't allow you to do that usually. But anyway, okay, Scott.
I was going to make another a alternative suggestion which doesn't involve the which avoids the issue that Paul brings up about different spies being handled differently. Just have a IKE message that goes to the other side which says, "Please send me back a dummy IPsec packet." If you receive the dummy IPsec packet, you have connectivity.
It's a one-way solution. Yeah. Yeah, so we've seen like on my firewalls, I've seen connectivity issues in both directions, unfortunately. Yeah, you don't know which way it could be, right? Yeah, so.
And actually, I have seen this in IPv4.
Okay, then people normally already discovered that, but now what we are seeing, right, is firewalls behave differently for VCs.
Yes.
Yeah.
All right. Okay.
Okay, so like, yeah, I don't know the feeling of the room, and like, do you like to discuss more adoption or?
Let's move the discussion on the list and
thank you.
All right. So. All right. Go ahead.
Okay. Hi everyone. My name is Wei Pan. Today, I'd like to introduce the idea of share the use of IPsec kernel in a multi-VPN environment. Next slide, please. First, I'd like to introduce the background of using IPsec in a multi-VPN environment. First, let's assume 2 devices and 2 VPNs, and these 2 VPNs are using the same IP address spaces. Next slide, please. And if we want to establish IPsec kernel to protect the traffic for these 2 VPNs, and if we only establish one IPsec IKSA for these 2 VPNs, you can find out that you can't negotiate any VPN-related information when creating the child SA. So the receiver doesn't know which traffic will be bind to which VPN. And next slide, please. In order to differentiate the VPN, it's necessary to establish 2 different IKSAs and bind to different interfaces. And then the receiver will know which VPN the traffic is associated with based on which interface it receives the IPsec data packet. Next slide, please. Therefore, so you can see currently different VPNs need to use different IPsec kernels, that is different IKSAs and child SAs. Next slide, please. And that will be a problem for the 3GPP networks or mobile networks, because first, you can see the left picture. In 3GPP networks, 4 meshed IPsec kernels are established among these or their associated base stations, because the operator doesn't want to let all the traffic from base station A to base station B to go through the security gateway to detour to the security gateway. So this kind of direct IPsec kernel between the base stations are established for the traffic from one base station to another base station. Based on this, and when combined with another feature, is called RAN sharing. Because the establishment of the infrastructure is very expensive, so the operator who owns the infrastructure would like to share this, lease the infrastructure to other operators to remedy their investment, and these different operators are assigned to different VPNs to isolate their traffic and services. When combined these 2 features, you can find out that the IPsec kernel's numbers will be seriously boosted as the number of base stations and the operators sharing the RAN increases. So in nowadays, the base station currently has nearly 100 neighbors, and this the number will be possibly highly possible to increase in the future. And these thousands of SAs needed actually exceeds the capability of the devices. Next slide, please. So we try to fix this problem, and the solution, the core concept of the solution is to share the same IPsec kernel for different VPNs. And I think the core concepts include 3 steps. First is at least you need to negotiate whether the 2 peers support this new feature. And step 2 would be when create the child SAs, you need to add the VPN related information to correlate it with the traffic to be protected. And step 3 would be when you can send the IPsec data packets, you need to carry the VPN information in the data packets so the receiver can differentiate which VPN this packet is for. And our current design is to add the VPN attribute for each traffic selector when negotiating the traffic to be protected in child essays, and also extended the ESP and the edge header to carry the VPN info. Next slide, please. First step is we add a notify to indicate the support of this new feature. Next slide, please. Then we introduced 2 new traffic selectors, and when compared with existing V4 and V6 traffic selectors, these 2 new selectors contain an additional VPN ID field. And when creating the child essays, 2 peers will use these 2 new traffic selectors instead of the existing 2 V4 and V6 one. And one specific parsing rule is that first they need to group or pair the traffic selectors with the same VPN ID, and then processing the paired or grouped traffic selectors as usual. Next slide, please. Finally, we try to extend the ESP or AH packet format to convey this additional VPN ID field, and then the receiver can differentiate which VPN the inner traffic belongs to. Next slide, please. Also, we currently received some alternative solutions. First, is to split the 32-bit SPI field into 2 subfields. Part 1 is the VPN ID field, and part 2 is the actual SPI field. And this kind of solution has the advantage of no ESP or AH packet format change. But it also has some disadvantages like the scalable issues and the packet disorder issues, because when you shrink the SPI length and the actual SPI, you might not be sufficient of the actual SPIs. And the on-pass routers may have some load balance feature based on the SPI field, and when you fill the VPN ID subfield with the actual VPN ID, then this traffic will have a different SPI, so the on-pass routing may disorder these packets. And yeah, and the other option of is to use our notify or traffic selector just of the VPN ID rather than the extending the V4 and V6 traffic selectors. But I think this kind of a solution can't differentiate which V4 and V6 traffic selector is associated with which VPN. So you need to, one VPN, the traffic of one VPN will be all included in the SA. So this may cause unwanted traffic to be included. And also this another solution about user, how do you say, unified field called flow ID or something proposed on the mailing list. I didn't put in the slide. Yeah, that's as a proposal by others. Next slide, please. Yeah, and the solution may be not mature this time, but the problem we want to solve is from the real scenario. So we want to know whether the group think this problem is worth solving, and we are welcome any suggestions, comments, and reviews. Yeah.
Can you go back to the slide with the many VPNs on it?
Which one? This one.
Yeah, this one. So here in this case, you've got all these tunnels, and you're saying all these tunnels have the same IP ranges on the source and destination part, right?
Yeah.
So base station A has, let's say, a tunnel to 1111 to base station B and to base station D and to base station C.
Yeah,
This is the better A and B.
yeah, for two
to-
devices,
Right.
they will need to establish different IP essays. For the next slide, I didn't, for two devices, I didn't
Right.
draw the different IPsec kernels. Yeah.
But then first, because there's two different things. These are, you have multiple of the same tunnels to the same endpoints, and the other one was you actually have a mesh.
Yeah. Actually, the next slide, please. The mesh means that when you have no VPN, you already have mesh. And when you have VPNs, you need to, the meshed IPsec kernels times with the VPNs.
So you have multiple meshes at that point. So
Yeah.
the left side picture is having multiple. It's a one mesh for VPN 1, one mesh for VPN 2, one mesh for VPN 3.
Yes.
Each of those are using same IP addresses, but
Right.
each of the box, of course, is using different IP addresses, etc.
Right. So
The vast, or as of course could be use IPv6.
Okay.
Yeah, sure. But somehow, I guess you're marking which of these overlapping IPs actually have to go where, right? Somewhere you have to track this. It's not just the IP based on the IP source address, right? There's some marker you have somewhere that marks this for VPN 1 or for base station D in your kernel somewhere. So the question is, that marker, if you like the sec label traffic selectors send that over the IKE and you've negotiated that, then you don't have to transport that marker over the network in an ESP packet. Like, you don't need it in the format, right? Both endpoints have it.
I think you're right. But your solution
All right, Michael, next perhaps. Oh, do you have more? Okay.
Yeah, Michael Richardson. Yeah, I agree with Paul that I don't think we have to transport the VPN ID, provided that the two ends can put the metadata into their essays. So I don't think but I think that's also solution spacing. So ask, do you understand the problem? I think is the better question. I think you understand the problem better now. Yes? Do you understand the problem better now?
Yeah, I think that I understand the problem better now. In Linux terms, you would do something with, like, we're marking the escape buff and remembering that and keeping a net table and sending all this stuff. And so, so I don't entirely understand why we need something new.
All right, but let's bring that to the list, I think. Scott?
Cisco actually addressed this issue about 15 years ago. It was actually, what we did was what you originally talked about. We just didn't have the scalability. Well, the better way to express this problem is the various colors are basically different logical networks, which may or may not have overlapping IP addresses. You don't care, just that they're completely independent of each other.
Yeah, another reason why we want to use this, not only because of the sharing the same IP address space, but also, so many IPsec kernels increase the operation and the maintenance complex for the operators. So yeah, the operator also say they have a need if we can share the one IPsec kernel for different VPNs.
So actually, as I said, if you use IPv6 and each of the runs, each of the VPNs uses a separate 6/40 prefix, then you can put every single traffic in the same IPsec tunnel, because you can actually know from the IP address who it belongs to. But anyway, let's bring that back to the list, and because we are a little bit starting with out of time, so let's move to the next presentation.
Okay. Hi, Wei-Peng again. And this one is about the anti-replay status notification. Next slide, please. First, also the background, the IPsec Edge and the ESP protocols specify the details of sequence number generation and the verifications. In simple, when the anti-replay is enabled on the receiver, the sender must monitor the sequence number counter and ensure the counter doesn't cycle. And when the anti-replay is disabled on the receiver, the sender does not need to monitor the counter. But also in these RFCs specify that during the SA establishment, IPSEC implementation should notify the peer if it will not provide anti-replay protection to avoid having the unnecessary sequence number monitoring. Next slide, please. Yeah, but actually this kind of notification doesn't exist. So there will be problems in the high performance scenarios. First, in current situation is that because in high performance scenarios, the queues problem will cause the traffic, the packet disorder, and the disordered packets exceed the window size of anti-replay and cause a lot of packets being dropped. So the operator chose to disable the anti-replay function. And this result in a frequent request of child SA because you know, in high performance scenarios, the 32-bit sequence number are not enough sufficient to use and will be consumed quickly, resulting in frequent recurring of child essays. And the ESN extended sequence number can solve this problem, but it relies on the window of anti-reply to guess the high order 32 bits of the sequence number. So if you disable the anti-reply, then the ESN won't be available to use. So therefore, the child essays will frequently rekeyed because due to the unnecessary sequence number monitoring and the unavailability of ESN. So the solutions could be two ways. First is to avoid unnecessary sequence number monitoring. That is to add a anti-replay status notification. And then the second way is to allow the use of ESN when the anti-replay is disabled. Next slide, please. Yeah, I can explain that later. Yeah, next slide, please. First, about the anti-replay status notification. It's an easy way because the new notify payload can be added to indicate the peer whether I will provide the anti-replay feature, and this can be done in the IKEOS exchange or create a child SA exchange. And the payload format is quite simple because it only needs a status field to indicate whether I enabled the anti-replay or not. Sorry. The other question is related to the next page, because if you support the ESN without anti-replay, then whether you need to this replay be able to convey that I can do ESN without replay protection. Next slide, please. About unbinding the ESN from anti-replay, ESN relies on the window of the anti-replay to guess the high order sequence number. So if one IPSEC implementation choose to do ESN without anti-replay, then it must maintain a separate window for ESN. So that means the implementation needs two window mechanisms, but actually the code may be reused. So and due to the window size of anti-replay is not negotiable, so the window size for ESN may be also not to be negotiable. And this seems like that doing ESN without anti-replay is a unilateral act. One peer can choose to do this without notifying each other. So it can be discussed whether there's a need to notify the peer that I can do ESN without replay detection. Yep. Next slide, please. So The problem is whether this problem was solving in IPSEC and working group. And first, the anti-replay status notification is required by the AH and the ESP protocols, and this draft can fulfill this requirement. The other point is that unbinding ESN from anti-replay, whether it should be supported or covered in this draft or done in a separate draft or not do that. Yeah, that's all.
Valerie, go ahead.
Well, I think that the problem is more generic, and the problem is that sequence number, extended sequence number, use of extended sequence number is negotiated. So either both peer use it or both peer doesn't use it, while it should be a local matter. And for this reason, I think that the second approach looks, for me, looks more suitable in this case, just unbind ESN from replay protection, because replay protection is just a local matter. It should not be negotiated. So that's my opinion.
Thank you.
All right, this document. So one of the reasons actually why the ESP and AH says that we should be negotiated and the architecture draft says we don't is because architecture draft gets, or architecture RFC gets published much later, or not published but finalized much later. And during the process we actually realized that there is no point of negotiating this, and that's why the architecture draft says that, or RFC says that you don't negotiate it, you just always send a sequence number, because the sequence number is actually needed for ESN anyway, because the higher order bits of the sequence number are included in the integrity of the packet. So you have to keep track of how often it wraps anyway, regardless if you are doing anti-replay or not. So you are not going to get rid of the monitoring the sequence numbers even if you disable the anti-replay, because for ESN requires that. So if you are not doing ESN, then you can actually just ignore completely the sequence number, but otherwise but that's the history of why it says this way. Paul.
So there is. So the problem right now is that when people think like, oh, why is my performance not happening? Let me just disable replay window protection, and they're shooting themselves in the foot because now they're disabling ESN, right? And that is fairly implicit. It's not very clear. So having these two things completely separated, the code is usually the same. So for instance, in Tero's famous words, the Linux kernel is doing it wrong. The Linux kernel is using the same code for replay protection and for ESN monitoring. So you cannot do one and not the other. So I would be interested to know what other big vendors are doing. I know that the NVIDIA Mellanox cards, they can do it separately. So you can disable replay window protection and still have ESN. And also Stefan Klasser, who's working on what we maybe call ESP v4 or WESP new version. He's thinking of to avoid this problem is to just put the entire 128-bit sequence number in the packet instead of just the 64-bit parts. So it might get solved separately if that initiative moves further. But yeah, I think that this would be good to signal across. And indeed, it's not negotiated. It's just a notify saying what you do for replay protection. But I think that there's a lot of value in saying whether you can do ESN without replay protection.
All right, so I think we bring that back to the list and talk about there, because we are getting a little bit delayed. We might still make it to the rest of the slides.
Okay, thank you very much.
Yep. All right.
Okay, hello everyone. I'm Liang Xia from Huawei. I hope that I can save some time for you. This is a very simple draft. Actually, China has a national standardization of the cryptographic algorithm. So, and it also standardized in ISO, in the in the international organization. So this is the background. Actually, the goal of this draft is that we just want to incorporate this local standardization and apply it to the IPSEC without changing any IPSEC protocol itself. Okay, so just a little background about this cryptographic algorithm. We have SM2, SM3, and SM4. Sorry, it's a typo. And SM2 is the asymmetric cryptographic and support the digital signature and the key exchange. And okay, and SM3 is a hash function which have the 256 output, and the SM4 is okay, sorry, is a symmetric encryption algorithm, and they all have the ISO standard already defined and the Chinese standard here. Okay, next page. Okay, here, like I said, we don't need any changes on the IKE version 2 protocol itself. Just introduce several new and register for the transfer type and method to the current IKE definition. Totally, we have 6 new items need to register as a new one. And the first 3 is about the transfer type 1, the encryption algorithm transfer, which include the CBC, GCM, and the CCM. And the last 2 support the AED capability. And the transfer type 2 is PIA functions. And we also include the integrated algorithms transfer type SM3. And we support okay, we introduce a new key exchange method is curve SM2. And another 2 method is for the hash algorithm SM3 and for the authentication method SM2 digital signature. So we have the draft with this index and describe every transfer type and every method. And together in the IPSEC, we have the test vector. Next slides. And in the security consideration, we have stated that at least at the time we're writing this draft, we don't find any weak keys for these algorithms. Yeah, weak problems. Okay, and we list some of the academic crypto analysis document papers for these crypto algorithms. You can check. Yeah. Okay, and next page. Okay, and in last period we have some discussion and we get good suggestion from our security AD, and usually these new algorithms introduced in the IPSEC or current IETF protocol, we have our current official process is IC, independent submission editor process. So I think this is a good suggestion. So we will try to follow this way to adopt this new register for the IPSEC protocol. And of course, we should involve the IPSEC working group expert review for this process. And another 2 technical questions is about whether why we still keep the CBC model right now. I think this meant because of the backwards capability, because currently the IKE is still have this. Yeah, and about the hardware, CPU hardware instruction, we support the multiplication instruction to speed up the G hash. Okay, that's all. And yeah, we want to get some suggestion from the group. Yeah.
Any comments, questions for that? Valerie, you start first.
First, thank you for bringing this document to the IPSECME working group, and I think that it should be really reviewed. But still, I think that it's better to proceed it further with independent submission, as the other national standards do. But still, I have some comments. First, the document defines a new authentication method based on digital signature, SM three or four. Well, okay, and the generic guidelines from IQ2 requirement for using algorithm, the latest RFC, well, it's 8247, is that the authentication method, the generic authentication method, digital signature, is preferred over authentication method tied to a particular algorithm. So you'd better don't define a new authentication method tied to your signature algorithm. It just define algorithm ID to be used in the generic authentication method, signature algorithm. Then, after reading your draft, I believe that you want to allocate both code points for using in ESP in NIQ2, and the draft currently only explains how to use, how to form a payload, encrypted payload for IQ2. It doesn't talk anything about how ESP should be formed. It's very similar, but still it should be spelled out how ESP is formed. And I think more details should be put into whether IOE is, what is format of initialization vector. It's better just to make a picture and describe it in more details. How key material is derived, because for the IES GSM, you derive nonce from key material. It is unclear from a draft whether you make the similar thing, or it's just tell you must get nonce, unique nonce from somewhere. So more details are needed. But anyway, thank you.
Okay, thank you, Larry. Your comments are yeah, I know. So we will take a look and yeah, make some improvement. Yeah.
Ballard, just a small process, Greg. The draft currently says that its intended status is standards track, but if you go to the IEC, you cannot be standards track.
It's okay.
So that just needs to.
I think the goal is that you know the IPSEC can support some new good cryptographic algorithm. Okay, thank you.
Dan Harkins. Yeah, I agree with Paul. I think the ISE is the best way to do this. The ISE was used for advancing these ciphers into TLS, so it's probably do the same thing with IKE. I really don't understand the thing about CBC though. There's no backwards compatibility that you have got to worry about because you're adding new ciphers, so you're not backwards compatible with anything really. So
yeah, I mean the current IKE still keep the CBC model. So
yeah, but that's for AES, right? You're not being backwards compatible with that.
Yeah, we can consider.
You're adding a new,
yeah,
you're adding a new transform or a new cipher, right? So
I know
your
point.
There's nothing backwards compatible to support with this with SMX.
Okay, thank you.
All right, let's go next. Daniel.
Hi. So I think I already presented those drafts before. There has been some discussion on the mailing list. So it's just to recap, a short recap of what we've done so far. Regarding this draft, we haven't changed much, even though it has been discussed. So it's relatively in a stable version now, and we can see next slide. So the purpose of this mechanism is really to avoid when the reassembly operations. And so we create two notify payload, one which is called the link maximum atomic packet, and another one which is the packet too big extension. So the latest packet too big extension was heavily discussed during the last presentation and on the mailing list. So just to recap, it's not mandatory for that for what we do. But we just came out to think it's probably the best way is to keep it. So if people are really willing us to remove that message, we could, but we still think it's better to keep it. Next slide. So the situation we're trying to solve is when you have a mid-tunnel fragmentation. So it means your ESP packet is cut in the middle in two packets. And then, next slide, when the receiving gateway receives that packet, it just sends back either a fragment, it sends back LMAP notify payload with the version and the fragment length, and if it really can't process the packet, if the packet is too big, then it sent a packet too big notification payload in IKE. Next slide. So this is what happens. So as I mentioned, the packet too big, the main advantage of the PTB message is really to carry the LMTU and the EMMTUR, so that the other gateway is aware of those values. And we prefer, one suggestion was to use a configuration, but we do prefer to have that to be dynamically configured and be able to change. So that's why we keep that message and that way to proceed. Next slide. So at the end, when you receive the fragment, you make sure that the peers in your network adapt the tunnel MTU so that no fragmentation is happening in the middle. Next slide. So it means either you have a source fragmentation or inner fragmentation being performed by the gateway, of course, only for IPv4 packets. But at the end, on the next slide, we can see that, I mean, there is no reassembly operations at the end. So this is what we wanted to achieve. So next slide. So basically, we really consider very carefully all the comments we received, and we really took those into consideration and clearly said what we do. So we really responded to every comments. So PTB, as I mentioned, is already mentioned into one draft from Joe Touch. And the main advantage of that message is to carry the EMTUR, as I mentioned. We still have one disagreement with Joe Touch, and it's regarding how we configure the tunnel MTU. So in his view, I mean the tunnel and the link, the tunnel and the link layers are independent, and fragmentation is ensuring that independence. While in our case, we're making the MTU for the tunnel so that there is no fragmentation. So we do not have the link and the tunnel being as independent as in the interior tunnels draft. But this is something that is currently done in IPSEC, and we just do something that is already been described in 4301. So I think that's acceptable. So that's all for this draft. Then the next presentation is it's the DSCP notification payload. So what we so the initial idea we had is to be able to split, to establish some security association that are based on the DSCP. So when we do have traffic with different quality of service, we can split them into different security association so that we can avoid reordering and some packets to be rejected because of the anti-replay protection. So next slide. So in the first version of that draft, we came with traffic selectors. So we were defining DSCP as traffic selectors, but this has been changed. And currently, the idea is that we are only using a notify payload and not negotiating so much, but simply advertising, notifying the other peer what we're doing. So for each essay, we're mentioning if we're associating to that essay some specific DSCP values. So yeah, next slide. I think it's gonna be easier to see that. So here we have different ways to proceed. So you create your child essay. In the second line, you can see that we have a notify payload that mentioned that DSCP values AF11 and AF3 are carried from the initiator to the responder. And potentially the responder could respond with a notify payload just to confirm he understands the what we are doing, and in many cases we expect that the response is going to be the same, but as you can see, we do really support. It's not mandatory that a response being sent, and the initiator should support. I mean, it should work as well without any response, because it's simply a notification. That's what needs to be reminded. So next slide. Yeah, so that's basically all. So again, I mean, I think there is a kind of consensus for that way to do, and I don't remember any comment that has not been addressed in this draft again.
All right, we have 3 minutes, so I don't think we have too many time. So too much time here to take comments on here. We probably want to have more comments. What? These are actually waiting for AD, or actually, I have to talk with ADs to think about this, if these are actually in scope or not in our charter. We were supposed to have this discussion in Prague, but we then actually didn't see each other or something like that. So we have to think about that and talk with ADs first and see if we need to recharter for this or can we include it directly.
I'll talk to Deb in the handoff
All right, good.
To work this out.
Yeah, because I think these are clearly an extensions. I'm not sure if they are minor extensions. That's actually the reason why I'm thinking about this. And some of them are, some of them don't. But I think I have to. I want to get AD's comments on that. Okay. Go ahead. Okay, so I think that's enough for that. Do you have some? I assume, or do you have a question for this or for the?
For this.
Okay.
Stupid question. What is the receive when the receiver gets this notify about what DHCP values? What does it do with it?
So I mean, it doesn't have to do anything. So it works. It also works if it doesn't if it does not support the extension. it's mostly if he is also doing some traffic selections. In that case, it's good. It's good he knows what the other peers is doing, so that he can handle that. And we expect to have some sort of segregation of the traffic.
So I'm sorry. So if the sender sends a
So the idea is that if the sender sends a list of them and the other end has the same set of lists, like they usually have for configuration, he can send the same list back, meaning that they try to keep all of that traffic in same SA pair. And it's just for for their internal use, to the same SA pair is used for the same traffic. It's not necessary, the other end can do whatever they like, but sometimes it's a good thing, especially for statistics and that kind of thing, if you can say that this SA pair is for this kind of traffic, and telling that what you are doing in the SA is allowing that, if I understand correctly, Daniel.
Yeah, that's it.
All right. Okay, so then we're out of time, so that's it, and we will see next time in Vancouver, I think.
Hi.